The reactant has epoxide and alkene when it is treated with H plus and H2O. So initially lone pair attract the proton and form oxonium ion. Now within the molecule nucleophile is there, so nucleophile attack ring opening takes place. Therefore corresponding structure like this. Now it reacts with water and finally it gives the corresponding product like this, tertiary alcohol and primary alcohol. So it is a first compound. Now it is treated with KMnO4. Now it is treated with KMnO4. Primary alcohol undergo oxidation. Tertiary alcohol do not undergo oxidation. Therefore, primary alcohol part oxidized to corresponding carboxylic acid. The reactant has ether functional group. It is treated with excess of HBr. Excess of HBr. We know the basic reaction. When ether treated with the HBr, lone pair attract the proton, corresponding oxonium ion will form. Now it react with Br minus. So nucleophilic substitution takes place and corresponding alcohol and alkyl bromide will form. So for primary SN2 type of reaction, secondary and tertiary SN1 type of reaction takes place. Therefore here it is a primary carbon. It is a primary carbon. So initially lone pair attract the proton. Corresponding oxonium ion is formed. Now it reacts with Br minus. SN2 type of reaction. And it is corresponding product. Now it react with again HBr. Another ether molecule react with corresponding H plus. Now it react with the Br minus through SN2 reaction. Therefore finally it gives corresponding product catechol. Finally it gives corresponding product catechol and CH2Br, CH2Br. It is a ethylene dibromide. Ethylene dibromide. So we got corresponding catechol and ethylene dibromide. Now this product mixture treated with oxalic acid, in the presence of H2SO4. Now here leaving group is present. So these two are the leaving groups in acidic medium. Therefore definitely we should look for the nucleophile. Now here it is a nucleophile. Nucleophile attack and a nucleophile attack. So this overall reaction is esterification. Therefore the corresponding product is so it is a oxalic acid part. This is a oxalic acid part. So this is a simply esterification. Therefore the final products are corresponding diester and ethylene dibromide. So these are the final products. So here we are having alcohol functional group, aldehyde functional group, alcohol functional group in the presence of H plus. So we know one basic reaction when aldehyde treated with ethylene glycol molecule in the presence of H plus. So simply remove the H2O and the corresponding product is RCH oxygen oxygen like this. It is a acetal, cyclic acetal. Similarly, if I observe the first reaction, it is an alcohol group, it is an aldehyde group, and it is an alcohol group. So simply what we can do, we can remove the H2O like this, and the corresponding product is like this. So it is a acetal. So it is a bicyclo heterocyclic compound. Heterocyclic because of oxygen and two cyclic rings are there, bicyclo compound. Now it is treated with two equivalents of Hi. Suppose one equivalent is added. Lone pair attract the proton. Corresponding oxonium ion is formed. And here ring opening takes place because of possibility of SN1 mechanism. C plus will form. Now the C plus react with I minus. Therefore corresponding product is formed like this. Again it reacted with another molecule of Hi. So lone pair attract the proton. Now here leaving group will leave because C plus can be stabilized by resonance effect of iodine. Now it react with I minus. So this is a final compound. Our final compound is this one. So first reaction is acetal formation. Second reaction is ether cleavage in the presence of Hi. So here we are having the functional group ether and ether treated with the excess of Hi. So the reactant is similar to this one, PHOR. When treated with the excess of Hi, O lone pair attract the proton and corresponding oxonium ion will form. Now it react with I minus attack on the R, leaving group will leave. It gives phenol and alkyl iodide. And we know that phenol won't react further with Hi because benzene connected to OH is not leaving group. So here SN1, SN2 not possible. That's why there is no reaction. Similarly, here we are having the three types of ethers. First ether, second ether, third ether. When we add excess of Hi, this bond will break, this bond will break, this bond will break, and finally it gives corresponding 1, 2, 3 triiodocyclohexane and 3 moles of phenol. First phenol, second phenol, third phenol. Now we know that 1, 2 diiodo compound is unstable. 1, 2 diiodo compound is unstable. Immediately it loses I2 and forms corresponding allyl iodide. Allyl iodide. Now it again react with Hi because alkene can react with the corresponding Hi, forms stable C plus. Now it react with I minus and finally we get corresponding diiodo compound. Again we are having 1, 2 diiodo compound that is unstable at room temperature. Therefore immediately loses I2 and forms corresponding cyclohexene. Now this cyclohexene again react with HI, electrophilic addition takes place, C plus will form, and the C plus react with I minus and forms corresponding alkyl iodide. So this is our final compound. Therefore here we are having corresponding alkyl iodide and phenol. Alkyl iodide and phenol. Now this alkyl iodide, phenol won't react with dry H2O or moist H2O, but alkyl iodide. So when alkyl halide treated with the dry Ag2O, answer ether. If I add moist Ag2O, answer through SN1 mechanism, answer alcohol. Because moist Ag2O means AgOH, Ag plus OH minus. Therefore here SN1 type of reaction takes place. Similarly, in the given question, we got finally alkyl iodide. When it is treated with the dry Ag2O, it forms corresponding ether ROR. When it is treated with the AgOH, moist Ag2O, Ag plus and OH minus, through SN1 mechanism, initially C plus will form. Now the C plus react with OH minus and form corresponding alcohol. The reactant has alkene functional group and alcohol functional group. Now it is treated with HgOAC2. So alkene react with the mercury and forms corresponding 3-membered ring. Corresponding 3-membered ring. Now here within the molecule nucleophile is there. Therefore intra-SN2 reaction takes place. Nucleophile attack at the stable carbocation, ring opening takes place. Therefore 1, 2, 3, 4, 5, 6. 6-membered ring formation takes place. 6-membered ring. So for better understanding, we are giving the numbering 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Second carbon, third carbon, fourth carbon, fifth carbon. The fifth carbon has HgOAC. And the sixth carbon has 2 methyl groups. So O lone pair sixth carbon with attack అయితే ring open అయింది. So ring open అయితే fifth carbon దగ్గర HgOAC. It is treated with the NaBH4. So through free radical substitution, so it loses a mercury. Finally we get corresponding ether. In place of mercury we should write simply hydrogen. Now we got the ether. Therefore here the product is corresponding ether. Now it is treated with 1 equivalent HI. So it is a ether functional group. So O lone pair attract the proton and corresponding oxonium ion will form. Since it is a tertiary carbon, ring opening takes place. Finally it gives corresponding tertiary carbocation. Now the tertiary carbocation react with I minus and form corresponding alkyl iodide at that carbon. Therefore the final compound is here OH group and here iodine group. So whenever tertiary carbon is there, when we add 1 equivalent HI, I minus always attack at tertiary carbon. Epoxide treated with nucleophile, pH C triple bond C minus, it is a nucleophile. So nucleophile attack at primary carbon, ring opening takes place. Because this reaction follow SN2 type of reaction, and SN2 we know that primary is more reactive than secondary, secondary is more reactive than tertiary. Therefore the corresponding product is like this. So it is our corresponding product. O minus will form, of course, here. And after acidification, corresponding product is like this. So this is our final product. Now we got this product here. Now it is treated with H2PdBaSO4. So it is called Lindlar catalyst. Lindlar catalyst. And Lindlar catalyst with alcohol, no reaction, but with alkyne, partial reduction. Partial reduction. Therefore, corresponding structure of partial reduced product is cis-alkene. So it gives corresponding cis-alkene. The alkyne will be converted to cis-alkene in the presence of H2PdBaSO4. So it is a partial reduction, and here BaSO4 act as a poison for catalyst. So BaSO4 reduces the activity of H2PD. Therefore, here only partial reduction takes place. The reactant has alcohol functional group. Now we are adding ketone. So when ketone treated with the glycol type of compounds, so in the presence of H plus, simply we remove the water and form corresponding acetal. So like that, in this case also, one OH group is above the plane, OH group is below the plane, and OH group is below the plane. When it is undergoing reaction with ketone, it is a trans part. This part is trans part. So two OH groups are opposite side with respect to plane, but this part is cis part. So cis part react easily. Therefore, we remove the H2O, and the corresponding product is like this. Because in the cis part, two OH groups are same side, therefore we can remove the water or ketone undergo reaction easily. If both groups are opposite side, that react slowly. If two OH groups are opposite side, and if two OH groups are same side, so here cis is more reactive than trans. Because of geometry, cis is more reactive. So therefore, it is our final product. Now it is treated with PCC. So PCC is pyridinium chlorochromate. Pyridinium chlorochromate, and it is an oxidizing agent. PCC is oxidizing agent. Therefore, here secondary alcohol is there. Remaining functional groups are ether, ether, ether. Ether do not undergo oxidation. Only secondary alcohol undergo oxidation. Therefore, the corresponding product is ketone. It is our corresponding product. The reactant has carboxylic ester, secondary amine, and carbonyl chloride. Carbonyl chloride. And we are adding the poisoned H2PD. So we know that only RCOCl react with H2PdBaSO4, and this functional group undergo partial reduction. Finally, it gives corresponding aldehyde. So this reaction is Rosenmund reduction. This reaction is Rosenmund reduction. This reaction is Rosenmund reduction. But when we take the carboxylic ester, H2PdBaSO4, no reduction. When we take the secondary amine, H2PdBaSO4, no reduction. That's why Here the structure is, after addition of H2PdBSO4, the ester won't be affected. It is a corresponding ester. Now the COCl will be converted to aldehyde. It is a reduced part. Now it is treated with dibal. Now it is treated with the dibal. So dibal, we know that dibal with aldehyde, no reaction. Dibal with the secondary amine, no reaction. But dibal with the carboxylic ester, reaction takes place. Suppose it is carboxylic ester. When it is treated with the dibal, so this dibal H minus attack, leaving refill leave. Finally, it gives corresponding aldehyde and alcohol. Similarly, here also hydride attack on the carbonyl carbon, leaving refill leave. Therefore, final product is, if I take acidification grantedly, it is our final product. So here corresponding ester is converted into aldehyde and alcohol part. The reactant has alkyl halide functional group, alkene functional group, and amide functional group. Amide functional group. And we know that dibal react with the amide, tertiary amide. For example, RCONR2. It is a tertiary amide. When tertiary amide treated with the dibal, simply nucleophilic substitution takes place, and finally it gives corresponding aldehyde and secondary amine. Similarly, in this case also, H minus attack, leaving refill leave, and acidification I am taking grantedly, aldehyde and corresponding NH group. It is a final product. Now it is treated with the HBr, H plus and Br minus. So aldehyde with HBr, no reaction. Aldehyde with HBr, no reaction. ఎలా ఫైండ్ అవుట్ చేయగలిగాము అంటే, ఫర్ ఎగ్జాంపుల్ ఆల్డిహైడ్తో ఒక హెచ్బిఆర్ రియాక్ట్ అయింది అనుకుందాం. ఓకే, బిఆర్ మైనస్ అటాక్, పై బాండ్ విల్ బి షిఫ్టెడ్ and corresponding product is RCHOH and we know that same carbon having the halogen and OH, it loses HBr, immediately it gives corresponding aldehyde and HBr. Therefore overall reaction is no reaction. That's why aldehyde with HBr, no reaction. Aldehyde with amine, just acid base reaction, because it is a base, it is an acid. Therefore the corresponding product is, when NH is reacted, when it is reacted with the HBr, H plus and Br minus, H plus take the proton, NH group take the proton from the HBr and corresponding salt will form. Corresponding salt will form. It is a salt. Again it can react with HBr because we are having alkene. Alkene react with HBr and form stable C plus. Stable C plus, because of plus R effect, it is a stable C plus. Now it react with corresponding Br minus. So it is our final product. So here simply one is acid base reaction, other one is electrophilic addition. The reactant has two functional group. One is alkene and another one is carboxylic ester, and this one is also carboxylic ester. So we know that alkene do not react with LiAlH4, lithium aluminum hydride, no reaction. But when we take the carboxylic ester, when it is treated with the lithium aluminum hydride, so here we can take the reaction. Initially it forms corresponding aldehyde and alkoxide through nucleophilic substitution. Again it reacts with another mole of H minus, and finally it gives corresponding RCH2O minus. If I take acidification grantedly, and the corresponding product is primary alcohol, and here the corresponding product is alcohol. So these are the final compounds. Similarly here it is a carboxylic ester. It is also carboxylic ester. H minus attack here repeatedly. H minus attack here repeatedly. Therefore the corresponding product is alkene part, that is not participating, and ester part below the plane CH2O minus, acidification granted CH2OH, above the plane CH2O minus, acidification granted CH2OH, and the leaving group is here methanol, and here leaving group is methanol. You can compare with normal carboxylic ester reaction. General reaction to compare chesi manam answer రాయొచ్చు. Now it is treated with the Bayer's reagent. So Bayer's reagent is cold alkaline KMnO4. Cold alkaline KMnO4. It is a Bayer's reagent. So Bayer's reagent యాడ్ చేసినప్పుడు మనకి ఏమవుద్ది, ఆల్కహాల్ రియాక్ట్ కాదు, బట్ ఆల్కీన్ అనేది రియాక్ట్ అవుతుంది. దిస్ రియాక్షన్ ఈస్ సిన్ హైడ్రాక్సిలేషన్. This reaction is syn hydroxylation. Therefore the corresponding products are so here OH above the plane, OH above the plane, syn hydroxylation. Of course corresponding methyl is below the plane, plus OH below the plane, OH below the plane, methyl above the plane, methyl above the plane. So syn hydroxylation from the above the plane, syn hydroxylation from the below the plane, and these two molecules are diastereomers. These two molecules are diastereomers. The reactant has carboxylic acid functional group, and it is a carboxylic ester. It is also carboxylic ester, and it is also carboxylic ester, but the ester structures are not same. 3 different esters are there. So we know that alkene lithium aluminum hydride, no reaction. Carboxylic acid lithium aluminum hydride, simply the carboxylic acid part is reduced to corresponding primary alkoxide. Now by taking the proton from the solvent, it convert into corresponding primary alcohol. Carboxylic ester when treated with the lithium aluminum hydride, so here simply you can write the answer. CO group converted to RCH2O minus, and leaving group is RO minus. Directly you can write the answer like this, and corresponding product is RCH2OH and ROH. So leaving group is converted to ROH, and remaining part converted to primary alcohol. Similarly here, if I look carefully, so here reduction takes place. Acid part is reduced to primary alcohol, and here above the plane, so this carbon part is reduced, therefore CH2O minus, acidification granted CH2OH, and methanol, sorry, structure not like that, above the plane CH2OH, and the leaving group is methanol. Now here below the plane, so here also undergo reduction, therefore this carbon reduced to CH2O minus, acidification granted CH2OH, and methanol. Now here it is a carboxylic ester, it undergo reaction. So here OH group, it is a leaving group part, and the remaining group is CMe3 CH2O minus, acidification granted CH2OH. So here 3 carboxylic esters reduced to corresponding alcohols. Now we are adding excess of silver and 573 Kelvin. So we know that primary alcohol, when treated with copper, silver, gold at 573 Kelvin, that means 300 degrees Celsius, primary alcohol undergo oxidation, secondary alcohol undergo oxidation and gives corresponding ketone, and tertiary alcohol, suppose like this, it undergo dehydration and gives stable alkene. Primary alcohol aldehyde, secondary alcohol ketone, tertiary alcohol dehydration. So here we have to identify the corresponding alcohols, and it is a primary alcohol, it is also primary alcohol, it is also primary alcohol, it is also primary alcohol, it is a tertiary alcohol, and it is again primary alcohol. So this alcohol oxidized to HCHO, and this alcohol oxidized to HCHO, and this alcohol oxidized to corresponding CHO. Now look at the big structure. So here primary alcohol converted to aldehyde, and here below the plane primary alcohol converted to aldehyde, above the plane primary alcohol converted to aldehyde, and it is a tertiary alcohol. So tertiary alcohol undergo dehydration, alpha and beta dehydration. It is a tertiary alcohol part. Primary alcohol aldehyde, primary alcohol aldehyde, primary alcohol aldehyde, tertiary alcohol dehydration. And of course alkene won't be affected here. So this is our final product. It has two functional groups. One is alkene, one is carboxylic ester. And we know that generally lithium aluminum hydride do not react with alkene, but it react with the carboxylic ester and it undergo reduction. Finally, the corresponding product is CH3, CH double bond CH. And here this carbon undergo reduction, it gives corresponding CH2O minus, acidification granted OH. And the leaving group part is CH3, CH2, OH. It is simply C2H5OH. Now this mixture treated with MnO2, so it is a allylic alcohol. First one is allylic alcohol, second one is simple alcohol, and we know that MnO2 is a special reagent. It oxidizes only allylic alcohols. Normal alcohols cannot be oxidized. Therefore, this primary alcohol will be oxidized to corresponding aldehyde. Primary alcohol will be oxidized to corresponding aldehyde. MnO2 oxidizes only allylic and benzylic alcohols to corresponding aldehydes and ketones. The reactant is cinnamic acid. It is a cinnamic acid, and cinnamic acid treated with lithium aluminum hydride. It is a alkene part. So alkene with lithium aluminum hydride, no reduction, but carboxylic acid undergo reduction, and finally it gives corresponding acid part is reduced to corresponding alcohol part, CH2O minus, acidification granted, CH2OH. Now it is treated with SOCl2 and pyridine, SOCl2 and pyridine, and we know that when alcohol treated with SOCl2 and pyridine, it follows SN2 mechanism. Therefore, in place of OH, simply we write corresponding Cl. It is simply SN2 type of reaction, and SOCl2 is converted into SO2. The reactant has three functional group. One is cyanide and also called nitrile functional group. One is alkene. One is aldehyde. When it is treated with NaBH4, we know that NaBH4 do not reduce cyanide, NaBH4 do not reduce acid, ester, amide, cyanide, nitro, epoxide. So these functional groups cannot be reduced by NaBH4. Therefore here cyanide cannot be reduced, alkene cannot be reduced, only aldehyde will be reduced. Therefore the corresponding product is CH2O minus after acidification granted CH2OH. Now it is treated with dibal, diisobutyl aluminum hydride. So it is an alcohol part, it is an alkene part, and it is a cyanide part. Dibal alkene, no reaction. Dibal alcohol, no reaction. Dibal cyanide, reaction takes place. When the cyanide treated with dibal, diisobutyl aluminum hydride, isobutyl, H minus attack on the carbon, pi bond is shifted. The corresponding product is RCHN aluminum isobutyl. Now after hydrolysis, acidic hydrolysis or basic hydrolysis by heating, so here it undergo hydrolysis and the corresponding product is RCH double bond O. Therefore cyanide is converted to aldehyde. That's why here simply we can write the structure. Cyanide part converted to aldehyde by adding dibal H, and the remaining functional group remains as unaffected. Only cyanide part is oxidized. So it is a D plus glucose. The reactant is D plus glucose. So D plus glucose treated with NaBH4. NaBH4 is reducing agent. And we know that alcohol cannot be reduced. Therefore, these functional groups cannot be reduced. The only reducible functional group is aldehyde. H minus attack, pi bond shifted, and corresponding CH2O minus acidification granted CH2OH. Remaining part is unaffected. OH right side, OH right side, OH left side, OH right side. Only this part is reduced part. Now it is treated with HiO4, NaIO4. So we know that whenever the polyalcohol molecules treated with the HiO4, we have to break the CC bond. So this part will be oxidized to HCHO, and this carbon part will be oxidized to, because two times we are breaking the CC bond, that's why formic acid, and this part undergo oxidation, therefore formic acid, and this part undergo oxidation, formic acid, and this part undergo oxidation, formic acid, and this part undergo oxidation, formaldehyde. So if I break one CC bond, one time oxidation. If I break two CC bonds, two times oxidation. Therefore finally we are getting 2 moles of formaldehyde 1, 2. And 4 moles of formic acid. 4 moles of formic acid. Not only HiO4, NaIO4, we can also use PbOAC4. PbOAC4. HO4 is known as periodic acid. HiO4 is known as periodic acid. So this reaction is periodic cleavage. Periodic cleavage. One comma 2 dihydroxy compound. So it is also called vicinal diol. It is also called vicinal diol. We are adding H plus. Therefore, here we are having two OH groups. When the OH group reacts with H plus, it loses water molecule. When it loses water molecule, C plus will form. When it loses water molecule, C plus will form. If both C plus are forming, stable C plus will form. So it is a corresponding stable C plus because of more number of hyperconjugation. We expect another carbocation also. By losing water molecule, we can form two carbocations. Among the two carbocations, we have to form stable carbocation. It is unstable, it is stable. Therefore, this do not form at all. It will form. Now, after that, migration is possible because of this lone pair effect. Octet is possible if this carbon get positive, and we know that migrating aptitude in case of octet molecules H minus, PH minus, R minus. Therefore, H minus will migrate, that is hydride shift. And corresponding stable C plus will form. Corresponding stable C plus will form. Now, O lone pair participate in the resonance and it loses proton. Finally, it gives corresponding ketone. It gives corresponding ketone. So it is our final compound. This entire reaction is known as pinacol-pinacalone reaction. So this compound is pinacol type and this compound is pinacalone type. Pinacol-pinacalone reaction. Now this pinacalone treated with ethylene glycol in the presence of acidic medium. So when I see the reactant, here ketone is there and here glycol is there. So whenever ketone reacted with glycol, remove the H2O from these two and write down corresponding cyclic acetal. So it is a cyclic acetal part. So it is a glycol part, it is a ketone part. Finally, it forms corresponding acetal. The reactant is phthalic anhydride. It is a phthalic anhydride. When phthalic anhydride treated with lithium aluminum hydride, so here anhydride carbonyl group will be reduced to corresponding primary alcohol. So it is a primary alcohol part and it is a primary alcohol part. So both carbon will be reduced to corresponding primary alcohols. Now it is treated with KMnO4 or K2Cr2O7. These are strong oxidizing agents. These are strong oxidizing agents. Therefore, we know that when the benzylic carbon having hydrogen, forget about the remaining carbon length, simply the benzylic carbon will be oxidized to carboxylic acid. The benzylic carbon will be oxidized to carboxylic acid. It is simply oxidation. The reactant has two functional groups. One is ketone, one is carboxylic ester. When it is treated with ethylene glycol is nucleophile. Ethylene glycol is nucleophile. So nucleophile can react with ketone, nucleophile can react with ester. But we know that general order RCOX more reactive than anhydride, than aldehyde, than ketone, than carboxylic ester, then carboxylic amide. So we know that aldehyde is more reactive than ester towards nucleophile. That's why here ester won't react, ketone react. And we know that with ketone and ethylene glycol, simply we remove the H2O in the presence of H plus and forms corresponding acetal. Since it is a ketone, it is also ketol. Therefore, in this case, corresponding ketol will form. Now it is treated with lithium aluminum hydride. It is a strong reducing agent and it won't reduce ether, but it reduces carboxylic ester, and we know that the basic reaction is carboxylic ester when treated with lithium aluminum hydride. So it undergo reduction and finally it gives corresponding alcohol. Therefore, similarly here, this part undergo reduction and finally it gives corresponding CH2O minus, leaving group is ETO minus. After hydrolysis, so definitely this ETO minus will be converted to ETOH and CH2O minus will be converted to CH2OH. Now here one more thing we have to think, it is a ether part. So to the ether part we are adding H plus H2O. Ether part we are adding H plus H2O. We know that when ether treated with the H plus H2O, simply it undergo ether hydrolysis, it gives corresponding alcohol and alcohol. Similarly here it undergo hydrolysis at this part and finally it gives corresponding CH2OH and this part is OH and ethylene part is ethylene glycol. If the same carbon having the two OH groups, it loses water molecule. Finally the corresponding product is ketone. At this carbon we get the ketone. So this is our final product. The reactant has one alcohol part, one amine part, and we are adding CH3COCl. It is called acetyl chloride. And here Cl is leaving group. Here chlorine is leaving group. Therefore we expect N lone pair attack and O lone pair attack. Two possibilities are there. And we know that strong nucleophile, nitrogen is stronger nucleophile than oxygen because it can donate electron easily because it is less electronegative, and oxygen more electronegative. So because of less electronegativity, nitrogen is stronger nucleophile. That's why here nitrogen lone pair attack and form corresponding amide. So this reaction is N-acylation. Now it is treated with benzoyl chloride, PHC double bond O Cl. So it is a chlorine, it is a leaving group. So again two possibilities are there. N lone pair can attack, O lone pair can attack. Because of resonance, here nitrogen part is weak nucleophile, oxygen part is strong nucleophile. Therefore nitrogen part do not react, oxygen part react, and finally the corresponding product is here NaHCOCH3 and here OCOPH. So this reaction is known as benzoylation. benzoylation. Now it is treated with lithium aluminum hydride, excess of lithium aluminum hydride, and we know that this functional group is amide. So when carboxylic amide, secondary amide, treated with lithium aluminum hydride, this amide part will be reduced to amine part. Amide part will be reduced to amine part. Now this is a carboxylic ester part. And we know that when carboxylic ester treated with lithium aluminum hydride, it undergo reduction. Finally, it gives corresponding RCH2O minus acidification OH, RO minus acidification OH. Therefore, in this compound, this amide part will be converted into amine part, and this ester part, we have to break the bond here, corresponding leaving group part and corresponding pH CH2OH. So ester is reduced like this, amide is reduced like this. The reactant has two functional groups, alcohol and carboxylic acid, treated with PCl5. So when alcohol treated with PCl5, it undergo SN2 type of reaction. Therefore, in place of OH, we write corresponding alkyl chloride. Similarly, when carboxylic acid treated with PCl5, so in this case also the OH part will be converted into Cl part. Now here, if I add only one equivalent, so which one will react faster? Here, if PCl5 react, O lone pair attack on the phosphorus, O lone pair attack on the phosphorus, and we know that this is a resonance participation. Therefore, it is a weak nucleophile and alcohol is a strong nucleophile. Therefore, in this case, alcohol part react, acid part do not react, because alcohol is strong nucleophile and acid is weak nucleophile. That's why here acid part remains as acid and alcohol part undergo SN2 type of reaction, corresponding alkyl chloride is formed. Now it is treated with alcoholic KOH. So here leaving group is there, alpha leaving group, beta proton. Therefore elimination takes place and corresponding product is COOH. So it is simply E2 elimination, alpha leaving group, beta proton. Now it is treated with H plus H2O, alkene react with H plus and form stable C plus. Of course, we expect here C plus like this also, but here minus R group is present. Therefore, it do not form at all. It is a stable carbocation. Now it react with the corresponding H2O and finally it gives corresponding alcohol part, alpha, beta. Finally, we got beta hydroxy acid. First one is SN2 type of reaction, second one is E2 reaction, and third one is simply electrophilic addition. Through stable carbocation.